afternoon. My name is Jennifer Wetzel. I'm the regional coordinator for the Philadelphia Future City competition. This is our 2021 engineering fair. We try and do something a little different every year to try and get students some information and resources for the theme. As you know, every year our theme of the competition is a little different. So this year, our theme is, as you all know, design a waste-free city that uses the principles of a circular economy. So our third speaker today is Chris Farley. He is the Vice President of Waste Management, Greater Mid-Atlantic Area. He joined Waste Management as a Senior Counsel for Mergers and Acquisitions in 2011. In this position, Chris represented the company's venture portfolio investments and advised on joint ventures, mergers and acquisitions, divestitures, antitrust issues, and general corporate matters. He began working in early 2018 and managing the company's business in Delaware, where he was integral to the development of Waste Management's new hauling station and compressed natural gas collection fleet in Laurel. In the early months of the pandemic, Chris was Waste Management's COVID czar and coordinated every element of GMA's response to the pandemic. Later in 2020 and through the first half of 2021, Chris led the company's operations in Western PA and West Virginia. He returned to GMA as its vice president in June 2021. Chris earned a Bachelor of Science degree in business from Indiana University, a master's degree in business administration and finance from Rice University, and a law degree from the University of Houston. So take it away, Chris.
Yeah, well, thank you. That's quite an introduction there. I appreciate that. Well, yeah, I guess it's good afternoon, everyone, and really happy to be here to talk about driving toward a waste-free future. And you know, given that introduction, you might think, what is a lawyer doing in the waste and recycling business? And I can tell you, you know, I worked at a law firm for about 6 or 7 years, and I worked as a lawyer at Waste Management for about 6 or 7 years, and then got the opportunity to move to the operating side. And it's just, there's all kinds of opportunities. It's a very interesting business. There's all sorts of potential for going forward, and that's really what attracted me to the operating side of the business. So with that, maybe we'll go to the next slide here, Ken. Yeah, there we go. So so Waste Management is a large national, I guess, international company. Our footprint, or where we operate, is in the United States and Canada. So that's the international piece. And we, as our name implies, Waste Management, we handle a lot of waste. You know, trash is another word for that. But we also are North America's, and I think it says it down there in the bottom left corner, we're North America's largest post-consumer recycler. So by post-consumer, we mean it's the trash that you throw away at home, right? It's the plastics, it's the cardboard, it's paper and aluminum cans and glasses in some cases. So we handle all of that material within our system. And so we have quite a footprint, and today we handle a lot of waste, and that part of our business is a little larger than our recycling business, but we are continually and constantly sort of striving to make the sustainability piece and the recycling piece a larger and larger part of our business. So a little bit about Waste Management here. So I think if you look at the three, or rather the 6 squares there in the middle, I don't know if that 48,250 employees, I don't know if that is accurate, but today, but give or take, we're around 50,000 employees, again, in the United States and Canada. And many of you in your neighborhoods, or when you're traveling around, you may see large green vehicles with Waste Management on the side, going through your neighborhoods, picking up you know, the toters at the end of your driveway, or maybe your apartment building or what have you. And those trucks, typically when you see tractors and trailers going up and down the highway, or large trucks, traditionally those large trucks are powered by diesel fuel. Diesel fuel is not necessarily the most clean burning fuel, and not necessarily the best for the environment. And so over, I don't know how many years now, maybe the last decade, we have continued to move our fleet And I don't, from a fleet standpoint, from the number of trucks that we have, if we're not the largest fleet in the country, we're certainly one of the number of trucks we have on the road every day. And we have transitioned that fleet from diesel trucks to clean burning natural gas, compressed natural gas. Those power a large percentage of our trucks. And so that's one way in which we try to further sustainability. And then with those trucks, so our trucks will park at the same facility each night, and they plug into a system that refuels the trucks with the natural gas. And in many of those facilities, 171 of those facilities, we have a public fueling station. So other trucks, and even in some cases, not commercial drivers, but just private vehicles can use that. Anyone can use those stations to fill up their natural gas powered vehicles as well. So that's an interesting twist that I think many people probably don't appreciate about our trucking fleet. And then waste management in general, it's like I said, it's a large company with a big footprint, a Fortune 200 company. So that gives you an idea of, kind of means we're maybe one of the largest 200 companies in the country, or at least public companies, publicly traded, like on the New York Stock Exchange or NASDAQ, those types of companies. And there's some designations here at the bottom, which we're obviously very proud to have achieved. 2021 World's Most Admired Companies, and a member of 100 Most Sustainable Companies. Those lists, we work very hard at what the waste we handle, the recyclables we handle. We work very hard to do that in a very safe way, and in a very, very much in keeping with all of the environmental regulations. And so we're very proud to sort of be on some of these lists. So then if you look, go from the middle there and sort of look to the left-hand side where it says 145 recycling facilities. So there are various types of recycling facilities. So again, most of it is sort of consumer waste. So after something has been used and it's been discarded, what do we do with it? So in many cases, and some that the students here today might be most familiar with, so you might have two toters at your house or a townhome or where have you, and one is for trash and one is for recycling. And we call there on the right of that, the circle on the left, and that says single stream, which is sort of the largest component there, the circle. That basically means in your recycling container, you're putting everything that's recyclable in that one container. So cardboard and paper and metals, aluminum, and the various plastics and so forth, all go in one container. And then we go around, we pick up those containers, we dump those recyclables in our trucks, we haul them to our recycling facilities, and then there's a process to sort all that material. So ultimately, for that material to be reused, it has to be sorted into its components. So the plastics need to go with plastics, the paper goes with paper, cardboard with cardboard, and so on. And believe it or not, so in fact, my water bottle here made of plastic, my eyesight is getting a little more difficult here, but there's a triangle on the bottom, and I believe it has a 1 in it. And so believe it or not, there are a number of different kinds of plastics. Generally, those triangles you'll see 1 through 7. And so you may not even be sorting all the plastics with plastics, but a particular type of plastic with its like kind of plastic, if you will. And then those are often, so it goes through the sorting process. It's a system of conveyors and magnets and blowers and some hand separation as well, that will often and then be compressed and baled and either put on a truck, sometimes put on a vessel or a barge, to ultimately go to the manufacturer that were used, for instance, the plastics or the metals or the paper, to make plastic products or metal products, or in many sense, the cardboard gets turned right back into cardboard, the boxes you may see from Amazon and other places. So in general, that's the largest part of that circle on the left that you see there. And then we're going to talk, quite a bit about technology today. So as you think about, the future city, technology is going to play a big part. And if you look on the left-hand side of that circle there where it says organics, and then above it, it says core organics, So by organics, we mean food waste. It's what you scrape off, sometimes maybe into the disposal or into the garbage can. It's what you don't eat on your plate at restaurants, that kind of thing. That food waste, there are technologies to do really interesting things with that food waste, and it can really be turned back into energy. So, food and other organics as well. So lawn clippings and tree branches and those types of things. Those also can be mingled with food and so forth. And that organic mix, that can ultimately be used to power our homes, to power, in some cases, to power our vehicles. It's really, there's a lot of technology around organics. And some of this technology is sort of in its early stages, in its infancy, but there's technology that can take organic waste and it sort of ferments, and it's a lot of chemistry, a lot of scientific process, if you will, and it can be literally turned into jet fuel. So the technology will be a big part of a sustainable future and future cities. So that's sort of a little bit about the recycling side on the left-hand side. And then if you go to the right-hand side, so we talked about a large part of our business is handling waste or trash, not just recyclables. Much of that waste ends up in its ultimate sort of resting place in a landfill. And landfills, you talk about, I don't think people really appreciate this. The engineering associated with a landfill is substantial. So, generally we call them cells. We build a cell. Those cells are lined so that it keeps everything, from actually going into the earth, if you will. And then we fill those cells with the waste. We often use big machines to kind of compress and compact the waste a little bit so we can make best use of that space. And then ultimately it gets filled with dirt, and essentially gets buried. And when that waste is buried and it's all there together, it decomposes. And as it decomposes, it produces methane. And methane is essentially natural gas. And so we have a collection system in our landfills that there's a vacuum, we literally suck out that methane. We collect it all. We call them gas collection systems. And we gather that methane and clean it up, and then it can be used just as any other natural gas to power engines, to make electricity. It can be put what we call back into the grid, not the electricity grid, but the natural gas pipeline grid. And it can be used for all the things that natural gas is used for, heating homes and generating electricity and those types of things. And then sometimes, depending on where our landfill is located, and maybe favorably located to industrial customers, we may, again, collect the methane, clean it up, and then send it to an industrial use that's close by the landfill. So we get beneficial reuses that way. So even what you might think as old technology in terms of burying waste in a landfill, there's a lot of engineering associated with those landfills, and we really try to use those landfills in a sustainable way to take some portion of the waste to generate power or electricity. So I think, Ken, now's probably a decent time to stop. And on the first video talks about traditional recycling, and you can see how plastic maybe gets turned into other things. And then after that, maybe we could play the second video, I think, which touches on landfill gas.
This pair of sneakers started out looking like this. So did this shirt, these jeans, and this backpack, and even this purse. All of this is made from recycled materials. WM and Reprieve have made it possible to transform over 20 billion bottles into amazing things we use every day. But how? How does this turn into this? Let's find out. Each year, 35 billion plastic bottles are thrown away. That's about 5 bottles for every human on Earth. And each of those bottles would take 1,000 years to degrade. This is how WM and Reprieve work together for a more sustainable tomorrow. Your recycling is picked up by WM, and that material is delivered to a WM facility where everything gets sorted. Plastic is separated from cardboard, along with aluminum, and other recyclable materials. Each type of material is packed into bales and shipped to various facilities to be turned into something new. Let's talk plastic bottles, for example. Millions of them are delivered to North Carolina, where Unify, the makers of Reprieve, operates one of the most advanced recycling facilities in the country. This is where bottles become yarn. Once the bottles arrive at the facility, they are sorted and cleaned. They get chopped up, melted, and blended to become Reprieve recycled flake. These flakes are loaded into massive silos where they begin a state-of-the-art process, which transforms them into polyester fibers. But not just any kind of polyester. This is super high quality, high performing fiber that can help protect against moisture, control temperature and odor, and deliver amazing cushioning. Then what? The bottles that WM provides are turned into millions of miles worth of yarn that's used by brands you know and love to create some amazing products. WM and Reprieve can make what seems impossible a reality.
Waste management has been very successful in their ability to collect different types of waste, and that's where we step in. We become that solution in terms of giving that bottle that second life.
We see ourselves as a company that helps brands meet their sustainable goals. We help brands achieve something that they thought was impossible.
Best of all, this innovative collaboration gives plastic a second life. So far, WM and Reprieve have taken 20 billion of these and given them a new life. And you can help by making sure your recyclables are empty and rinsed before putting them in your bin. And by buying products made from recycled material. When you think about it, this process starts and ends with you. And all of us can work together for a sustainable tomorrow.
That video is sort of related to the ring, in many respects, the ring on the left of our slide. Yeah, and then go ahead and play the second video if you can.
Okay.
Yeah.
This is a WM landfill. And what happens here might surprise you, like renewable energy production. WM sites just like this one help to produce enough energy that helps fuel the largest truck fleet in North America and power thousands of homes. Like everything technology touches, landfills have come a long way. And facilities like the one we're at today, this is an engineering marvel. Here's a crazy thought for you. Each year, WM oversees the safe disposal of millions of tons of waste. Millions of tons. And they do it smarter and more sustainably by figuring out how trash can be repurposed and reused. WM also collects millions of tons of recyclable materials, but a lot of stuff still ends up in a landfill. In fact, the average American creates 4.5 pounds of trash every single day. So the question is, how can we turn trash into an asset? When you collect tons of waste in a place like a landfill, it naturally produces methane gas when it breaks down. This WM facility turns that gas into usable energy.
The turbine plant produces approximately 3.5 megawatts of exported power, which translates into approximately 3,500 homes that can use electricity generated from landfill waste. This plant runs 24/7, producing electricity.
As we mentioned earlier, as organic material breaks down, it produces methane. And in a landfill like this one, that methane is trapped below the surface. It can be hundreds of feet down there. Just like an oil well pulls oil from the ground, this landfill has about 200 wells, like this one, that use vacuum suction to pull up the raw gas from the ground and sends it through these pipes to a super high-tech processing plant.
We can create biofuel from the methane gas that is created from that garbage. Our garbage trucks that actually come to your house run on biofuel. And what a cool process. We can pick up your garbage running on the garbage that you actually dumped in the landfill the prior week.
Okay, I got a fun fact. WM is the nation's largest operator of biofuel trash and recycling trucks. By using biofuel in its trucks, WM saves over 71 million gallons of diesel fuel per year. 71 million. It also reduces its carbon emissions by 30,000 metric tons from trash. That is mind-blowing, okay? Million tons of trash per year, and most of that ends up in a landfill. But what if every landfill across the country was tapped as an energy source? WM is doing its part to make a difference, and you can help by buying only what you need, donating unused stuff that can be repurposed, recycling right, and using a landfill as a last resort. You know, it's amazing to see the innovations that are happening here today that are going to make tomorrow even better.
All right, thanks a lot, Ken. And then we'll go back to the slides when we get the chance. I will say that those videos explain things and the visuals and so forth a lot better than I did, but hopefully it all fits together. And hopefully those videos kind of brought it together a little bit. Those are, it's a very, very good representation of what we do on a daily basis. Yeah, there we go. And then we'll just move on to the next slide. Okay, so we mentioned technology, and I think other folks today have talked about a circular economy. I think the plastics piece is a very good example of a circular economy where bottles like this one get turned into all sorts of products, right? Who would think that would be possible? But it's very good representation and example of how this can be turned into a number of different things. Then we talked a little bit on the prior slide also about organic waste and food waste. And so if you see on the bottom right here, those tanks. So again, we take food waste and again, grass clippings and tree limbs and those types of things. And ultimately, what we call our core process, so that's the COR and then the small, or the capital COR and then the small e there. We take that material, mix it up, and then what the product, if you will, what goes into those tanks is what we call an EBS, engineered bioslurry. And that bioslurry can be used to enhance gas production at certain facilities like wastewater treatment plants. And just as we're pulling the gas, the waste decomposes and generates gas in a landfill, and just you saw in that video where we have the vacuum and we're collecting that and using it to create energy, the bioslurry helps wastewater treatment plants essentially do the same thing. They create and generate more methane, more natural gas, and they do the exact same types of things, whether they use that gas to make energy in some form, whether it's powering an engine, whether it goes back into the natural gas pipeline grid and gets used, for many different applications. So again, this is another technology that takes food waste and grass clippings and so forth and turns it into power of some sort. So as you think about it, it's almost like maybe a sci-fi movie or something. As we go into the future, the things that we use on a daily basis, we can hopefully use to power all of our needs going forward. Power, the lights and the TV and everything, the heating and air conditioning, everything you use in your home and elsewhere. So we contribute to that now, and it is our plan and our challenge to contribute that more so in the future. And so again, we talk about landfills, which I think may be considered somewhat of an older technology. But again, I think the video did a great job of demonstrating the engineering that goes on, kind of behind the scenes in a landfill and what those facilities can be used for. But once they're they have a useful life, and once they have reached the end of that useful life, so you only have so much airspace. I talked about sort of we dig a cell and line it and then fill it in a efficient fashion, so forth, then ultimately cover it. And when a landfill has reached the end of its useful life, we call it a closed landfill. So a cap goes on top of it. And that cap is essentially an earthen cap, if you will. And as you can see in the bottom picture on the left there, often those caps, closed landfills have lots of uses. You'd be surprised, some are turned into golf courses and those types of things. But one of the ways in which we've been successful using closed landfills, so waste is no longer going in, it's no longer an active landfill, so it's just a closed landfill there, covered with grass growing on top. We can use those. It's a lot of land. So solar panels, solar facilities take up a lot of land. It's a good use for that land or property is a good use for solar panels. Also wind turbines and so forth. So we talk a lot about replacing fossil fuels with wind and solar, and our closed landfills contribute to sustainability in that way as well. So some other things that are not on the slide that are some technology that we use now. If you think about a future city, we have, and we are currently working on this. Again, a lot of this technology is in its infancy, but we have worked on the technology for self-driving trucks. So, I think you may be familiar with self-driving cars and where we are in terms of developing that technology. Well, there are folks out there working on the same thing with trucks. And so, you can imagine in the future, a self-driving truck that goes around the neighborhood, as you saw in the video, that collects does the exact same thing, right? Collects the toter there and puts it into the truck. Same way with our commercial customers. When you see maybe a larger bin that's outside of a restaurant or a grocery store or something, same type of thing. One day, likely an intelligent truck, if you will pull up to those bins in the back of those facilities and place the material in the truck, and then direct itself to another facility, which may be a landfill or maybe something else, where that ultimately that material gets used. So, and then those containers that are out back of, like I say, a restaurant or a grocery store, something you might see, they're not, in some cases, they're not just containers. There's technology in those containers as well. So there are technologies that can tell you when a container is full, can send a message that says, hey, come, empty this container because it's full. There are even, they can, through bouncing light and so forth, and then reading those signals back, they can estimate how much weight is in those containers. So again, a lot of these technologies are in their infancy and early on, but you begin to see how a future city might be sort of a smart city, if you will, with self-driving trucks, containers that tell you when they're full. And that's just really kind of at the outset. But and of course, engineering is a part of all of that, right? So engineering, math and science, chemistry and so forth will be an important part of a sustainable future and how we look at cities in the future. I think then, check on our time here. Ken, let's go ahead and go to the fourth slide. Yes, there's a lot of boxes here, right? We talk about the planet. We talk about waste management's journey to sustainability, right? Which we're trying to progress towards daily. So you see things here like maybe the second box under the notable progress column there, reduce GHG emissions, right? So greenhouse gas emissions. So you hear about greenhouse gas emissions often, right? They contribute to climate change, potentially global warming. If you look at that statistic there, we think, in one way we think about it is, what are our emissions as a company doing what we do? You saw some of what we do there on the video, and and we often measure the material that we handle by the ton, right? So 2,000 pounds. And so what do our emissions look like for every ton that we handle, right? And so we've been successful in reducing those greenhouse gas emissions per ton by 17% by 2013. So that's what that box there means. And then we talked about, they talked about in the video, and you saw an example of our trucks there. If you look at the box below that, again, the diesel trucks contribute more greenhouse gas emissions. So we look at it again, we drive thousands, if not millions of miles every year. And so what do our greenhouse gas emissions look like per mile driven? And because we've been able to convert much of our fleet, our truck fleet, from diesel fuel to cleaner burning natural gas. Since 2010, we've been able to reduce our greenhouse gas emissions per mile by 43%. So again, technology and always sort of striving to be more sustainable. And then if you look further a bit to the right there, in terms of our goals, you can see again, maybe the second box under the ambitious goals there, the one that reads 70% of our collection fleet to be alternative fuel vehicles. So we continue to grow our fleet to burn less and contribute less greenhouse gas emissions to the environment. I'm going to look at, I can't see all of that slide there. Much of these goals are built toward, like I say, sustainability, which I think is very much part of maybe the circular economy is a good phrase for it. Also, what future cities look like and the technology, all of that will combine to help us reach some of these goals, and then goals that we haven't even set yet, right? As each year, or really each month, each year goes by, right, we'll continue to revise these and make them more aggressive so that we do our part. And again, a circular and sustainable economy and future cities and the technology will be a big part of that. And then I think one of the things there at the bottom that the last set there with people, you know, we talked about it earlier around the very first slide. Waste management employs somewhere in the neighborhood of 50,000 people. I think it might be more than that today. And, you know, we can't do, even with all the technology and the trucks that you've seen there, and even with talking about self-driving trucks and so forth, and containers that can tell you when they're full or not, even with that technology, that still takes people, right? And today, they may do different things in the future, but our 50 some odd thousand employees are incredibly important to the company, and they're incredibly important to enable us to do what we do. And so we talk about a core value at Waste Management is people first. And so if we take care as a company, if we take care of our employees, they will in turn take care of our customers. All of that combines to help take care of the environment, given what we do. And then again, as things go in the future, again, those roles and the jobs that people perform may evolve, but they'll be just as important in terms of, again, a circular economy and sustainability and so forth going forward. So I think with that, as I look at the clock here, might have time for a few questions, but Ken, that covers much of what I was going to say. I may have left some pieces out there, but those videos do a nice job of explaining what it is we do, how we contribute to sustainability today, and hopefully I've given some insight as to how we might be able to, you know, that technology and what we're able to do in the future to drive towards future cities and more sustainability. So with that, I'm happy to take any questions.
So students, if you have any questions, you're welcome to unmute yourself and just ask the question to Chris. I would appreciate if you would identify yourself and what school you're from as you're doing that. You can also put your question in the chat, and if you could also put what school you're from there, that would be great.
And if there are no questions, that's okay. The talking in front of a group sometimes is not an inviting environment to ask questions. I don't know, Jennifer or Ken or anyone else here on the call, based on what we talked about here this morning, maybe what you talked about with some others this morning. Any questions from you might get the ball rolling a little bit.
Yeah, have you looked at like next generation electrically powered trucks?
Yeah, so that's a very good question. We have, and we have pilots that we're working on, by meaning sort of we're demonstrating some of those technologies in some of those vehicles. So doing it kind of on a bit of a smaller scale. You might, I guess at this point, I would say the technology for electric powered trucks is probably not there yet. If you think about it, one, takes a lot of power to those trucks are really big, they're really heavy, and they have range, right? They travel a number of miles. So there are some technological challenges that you have with a truck that maybe you don't have with a car. But they are out there, right? And so we are, like I say, we're using them right now in a limited fashion, and that technology will improve. And so it'll be a part of our fleet going forward. But the technology probably needs to improve a little bit before we're using it on a larger scale. And I saw something come up there in the chat. I don't know if, okay. Here we go. I'm from Fugit Middle School, if I said that correctly. And my question, I might have lost it. Hang on a second. And my question is, what are some of the recycling processes for glass and aluminum besides plastic and water bottles? Very good question. So metals are very easy to recycle. One, I mean, in the grand scheme of things. So one of the things, I think you may have noticed, sort of took some care to talk about, we are the country's largest post-consumer recycler, because there are steel making process, for instance. They recycle iron, it's called ferrous metals. So anything that a magnet sticks to, basically, they recycle literally, thousands, if not millions of tons. They take old steel, essentially tons. They take old steel, essentially melt it down and make new steel. And so they are, from a metal recycling standpoint, they're larger than we are. So that's why we're careful to say post-consumer for the products that we handle a majority of. Same way with aluminum. You talk about, your Coke cans, your Sprite cans, or what have you. Those get crushed, and you saw some bales of material. I don't know if they were aluminum can bales on those videos, but they look very similar to the bales that you saw there. Those go back to aluminum manufacturers. They melt that aluminum back into molten aluminum, and then they make aluminum products out of that, including cans. So it's their metals are very reusable, and so much of that, if it goes into the landfill, for us that might be a bit of a loss, because it has value, and it can be reused multiple times, sort of over and over, and make new products. Glass is a little bit of a challenge. So we talked about on that very first slide, and the ring on the left, we talked about single stream recycling and putting everything in one container, all the glass, aluminum, cardboard, and so forth. The glass breaks, and you might think about, you can easily maybe use a grapple to grab paper. You can use a magnet easily to attract iron. There's not anything that you can really easily use to handle glass. And so when it gets in with all the other recyclables, it gets very hard to capture in our processes. And then when it breaks down, it essentially breaks down into sand. And that fine sand, you saw some of our conveyor belts and so forth in the video, that sand wears on our conveyor belts. It's very difficult on our systems. So it's difficult from a consumer standpoint, particularly in single stream, to recycle glass. Now, glass in and of itself, it's also very heavy, right? And that creates some issues. The glass in and of itself, when it's sort of self-contained and segregated by itself, glass can be recycled very readily. But it is a challenge and turned right back into new glass bottles and things. But it is a challenge when it is commingled with all the other recyclables that we take today. And then let's see here. Let's see. My name is Dewar. Thank you, Dewar, for the question. I am from Pan American Charter School. Got it. My question is, in the future, will all electric be solar? I don't know. It's a good question. I think we're probably still, I talked about a lot of technologies in their infancy. Even though solar's been around for a while, the technology just continues to improve sort of with each generation. And so I don't know. My sense is that we'll be using the sun to power a lot of things, but I don't know that we'll provide all of our electricity. So some of the other technologies that we talked about, literally, like, the food waste and yard waste, using that to generate power. Wind, I think, will be a part of it. And as we sit here today, there will likely be some technology that, you and I aren't even considering right now that we'll use to generate power in the future. But certainly solar and the sun will be a big part of it. And it looks like maybe one more here from Sarah from Queens of Angels. All right. My question is, how do you plan on getting 100% renewable energy at your WM sites? Well, so, it's difficult right now. And I don't know that that's a very aggressive goal for us. I think, so we talked about the electric truck, right? So again, many of these technologies, again, are sort of their early stages. And as that technology improves, we'll be able to use more and more renewable energy to power everything that we do, right? So today we have some facilities that take landfill gas and we're able to power our trucks from that, right? So that is renewable energy in a sense. But I think we still use some trucks that are diesel fuel. We have more than trucks as well, right? We have you saw some of it there in the video. We have heavy equipment, right? The big, Caterpillar cranes and heavy, big trucks that you see and so forth. And so much of that still depends on fossil fuels. But we are working and striving to be more sustainable and achieve our sustainability goals every day. But we are, unfortunately, we're probably, I hate to put a time frame on it, but we're at least several years away from all of our needs being powered 100% by renewable energy, but we're working on it.
All right, well, we need to wrap up this session. Chris, thank you very much again. That was a really informative talk. And we will have the recording of this presentation up, the link to our website on our YouTube channel. So if you came in late or you had some other team members who are not able to attend today and they want to listen to the presentation, we'll have all of our presentations up. And we welcome everybody to exit out of this Zoom room and go over into the Ask the Engineer room to ask two of our engineers any questions you have. And we have our last presentation starting at 2. So thanks, everyone.
Yep. Thank you very much. Pleasure to be here today.